So our last presentation of the morning before we break for lunch is Christos Papadopoulos, who's going to be presenting BGPmon, the many new faces of BGPmon. So please welcome Dr. Papadopoulos.
Well, thank you very much. So this is the other BGPmon, the one that's coming from the academic space, as opposed to the other one that's coming from the commercial space. So I wanted to start by first thanking our sponsors. We've been supported over the years by the NSF, DHS, Cable Labs, and by the Australian government. So I am a professor at Colorado State University, which means I don't really do anything in terms of implementation. So for that, I have a team of people who actually do the implementation. And I want to specifically thank Spiros Thanasoulas, who's sitting here in the audience. He is the main implementer of the stuff that you're about to see. Conspicuous by his absence on the picture is John Kemp from RouteViews, who claimed that his face was too scary to put on the slides. I can assure you that's not the case. John is also in the audience, and he has been a tremendous supporter, tester, and consultant in everything that you're about to see. So I want to thank him very much for all his support. Okay, so this is probably not the audience to try to convince that BGP is still insecure. I think we all know that. And the several instances of problems that we have, prefix hijacks being a prevalent one, routing outages is another one, man-in-the-middle attacks where someone grabs your prefix, routes traffic through their own network, and then routes it back to where it's supposed to go while conveniently sniffing what you've been doing. While we're waiting for a good BGP security solution, the thing we can do is monitor BGP. And of course that's hard because BGP tends to have many, many local views, which means you need a lot of eyes to monitor, if you wanted to monitor BGP in its entirety. Many eyes, however, generate a lot of data. So that presents a challenge where we need to be able to collect all the data from many different places, process it, understand it, and extract interesting events. Extracting interesting events is actually hard. We know how to do prefix hijacks, we know how to do outages, but I am willing to bet that there's a lot of other really interesting events that's hiding in all the data that we don't yet know how to detect. The other important part of the equation is that once we have these interesting events, we should be able to notify the relevant parties about what happened. And sometimes that's hard. We're all familiar with the cases of too many alerts, too many messages that we don't necessarily know what they mean, and also the fact that sometimes these things come too late. Is this a real threat? Yes, I believe most of you here will agree. I've just collected just a few of the instances of security events that happened over the years. The BGP, the YouTube hijack is getting really old by now, but you guys are probably familiar with many other hijack events that happened more recently. From the outages, a famous one was Australia back in 2012 when Dodo convinced Telstra that it could reach the internet and the entire continent of Australia went out. Detours, you may remember the instance back in 2013 where Renesas detected a suspicious part between Denver going to Iceland and coming back. And that is actually really interesting. We have been doing a little bit of research on what we call international detours, and I'll talk a little bit about that later. But an international detour is briefly a path that starts in a country, comes back to the same country, and goes through a different country. Now, that's perfectly normal for traffic engineering reasons, but sometimes when these paths do not last very long, there could be an indication that something may be investigated. And I'm showing a couple of pictures on your left, showing statistics about how many transient detours we see, those that last only a few hours, versus how many long-term detours we see, which are probably due to traffic engineering. Okay, so the approach we're following is to combine two existing projects. RouteViews, the one that you guys are probably really familiar with. RouteViews has been around for a very long time, collecting a lot of data, making it available to the community. And BGPmon, a project that was tasked to take route use data and make the data available more easy to researchers and operators. Now, route views is operating about 500 or so IPv4 and v6 eyes, so there's a pretty good coverage of the internet today. And it's making the data available in a really simple and robust format, files that anyone can download and investigate. BGPmon tried to put an overlay on top of these files and make a more useful interface. And initially started to do this using custom software and based on XML streaming. Well, that turned out not to work very well, partly because XML streaming had the problem of matching speeds between consumers and producers, but also partly because the software that BGPmon was trying to develop was mostly custom. So how do we modernize this? How do we make it better? Well, in trying to rethink how the whole system would work, we set up a few goals. Some of them are expand the capacity, improve the robustness, and also modernize the user interface. So we wanted to be able to have not just BGP data, but add more data, and also make it more robust, which means distributed. We wanted to add additional information, such as ownership information, who owns what. We wanted to add things such as geography, where in addition to giving you prefixes, try to figure out where these prefixes are located, where these autonomous systems are located. And also provide the ability for you to deploy and run the system in a private manner. And I'll talk a little bit about later. The approach we decided to follow is to take a distributed database and essentially build BGPmon around it, and essentially make BGPmon able to run in the cloud. The other key decision was to try to get rid of as much as possible of custom code and utilize community code as much as possible, and take advantage of the improvements done by the community. And finally, we wanted to geolocate everything. So for example, when you saw a prefix hijack or an interesting event on a particular collector or from a particular peer, we wanted to be able to tell you geographically where that eye is located, so you can make appropriate decisions. So the new collector looks something like this, and the only custom piece here is the BGPmon daemon, which is essentially an orchestrator of all the community software that we're including in the system and interfaces with a distributed database. We're still keeping the ability to talk to routers and bring in MRT data, the thing that's shown on the left. We're using Go BGPD, with many thanks to our NTT colleagues for providing the software. We're using BMPD to bring in data, and of course we're supporting the legacy MRT infrastructure. As far as the user is concerned, the interface with BGPmon will look something like this. So the user is on the top, making queries to the distributed database, where all the information comes in. So on the left is routing, which is what we always had. And we also want to add information such as ownership, a prefix and autonomous system ownership. We wanted to add information about geolocation. We wanted to add information about traffic. And what that may include, for example, is information such as, wow, look at that, all of a sudden there's a lot of NTP scanning activity. That kind of information I think would be important to have in this database. So this is the type of public deployment that we are envisioning. So we would like to have the whole thing based on a distributed database with collectors and database nodes distributed around the world. We would still be the operations center, in Fort Collins and run the whole thing, but by distributing the whole system this way, then we think we can get both capacity, robustness, and speed of response from the users. One advantage of this system, for example, is that if Australia were to disappear again, then there will be a node in Australia that will continue to collect all the data while the outage is happening. And then when Australia comes back, then the data will come back and be added to the system again. Okay. So this is a slightly different twist about what we want to do in terms of private deployment. We were a little bit surprised, you guys may not be as surprised as we were, to find out that BGP is not just used to do global routing. A lot of people use BGP for other purposes that we have not thought of. For example, there's people who use BGP inside a data center to manage their topologies. There's cases where people may want to monitor their own particular infrastructure that is not available to the public. So this came out from a requirement from the Australian government. They wanted to monitor some of their classified infrastructure, but obviously they did not want to advertise BGP information from that infrastructure to the rest of the world. So that essentially convinced us that the ability to have BGPmon run in a private mode would be useful for a number of people. So what we are doing is essentially giving out the same software to everyone with the ability to run it in isolation. But we have a little bit of a twist. You could do that. You could take our software and run it in a completely isolated mode, private mode, without talking to the rest of the world. However, I do believe that in some cases, you may want to be able to take information from the public deployment, so do sort of a read-only information into your own system, so you can make better decisions about what's going on in your infrastructure, especially if your infrastructure is connected to the rest of the internet. So while you may not want to advertise, send BGP announcements to the rest of the world, it might be useful for you to bring in information from the rest of the world. And if at some point later you decide that, well, you know, the information that I have in my infrastructure is really not dangerous, then you should be able very easily to change your system so that it will become part of the whole BGPmon system. So the key point here is that we're building the software with the ability to run in any one of these three modes and making it very easy to switch back and forth. Okay, so coming to the services that we provide. So again, with many thanks to Spears for implementing these services, we are now providing a slightly different service in terms of collecting, or in terms of retrieving BGP information from the archive. Remember, the old service was an XML stream that you needed to tap in and then try to ingest the data. The new service is HTTP-based, so it's a pull-based interface, and it's also time-based. So what you can do is you can issue an HTTP request with a certain time interval, and then we will return to you the appropriate data for the time interval. So this is done by an archive that we run at Colorado State, which is up and running, and I have a URL at the bottom, and I welcome you to go there and give it a try. The archive contains everything that RouteViews has exported since 2001, which is a long time. And what you can get from the archive is things such as update messages, RIBs. You can get them in MRT format. You can get them in JSON. And you can also get them in protocol buffers. And I'll talk a little bit about that on the next slide. The other thing that the archive provides is the ability to do a continuous pull. So you can keep doing requests, pulling data out of the archive, so you can get a complete picture, you can get a whole stream of BGP messages. One problem that we faced in trying to do that is the fact that you can give a time range, but then the archive will return to you what messages it has up to the point when you made the request. But there's clearly messages that arrive later that belong to the time range that you've requested before. So how do you get those? So Spiros added this functionality where if you want to do a continuous pull, you do the request, and then you get back a token that you can provide a little bit later, and with that token, the archive will return to you whatever you've missed in the previous interval. So whatever arrived after you made the request. So I thought that was a pretty neat functionality. Okay, the protocol buffer interface, we developed that because we felt that a more direct way to access BGP data would be useful to people. One example of that is if you have a tool, an alerting tool that you're using that happens to be extensible, and you wanted to incorporate BGP data into that tool, then clearly a standard web interface is not going to do it because it requires a user. An HTTP interface will work, but maybe it's not the fastest. But a protocol buffer interface would essentially give you the ability to talk directly into the archive and pull the data that you want in a sort of an RPC style format. So we've implemented this, and there's libraries there that parse BGP messages. Another advantage that we got out of this is a reduction in the data size compared to MRT. And also because the whole thing is implemented in Golang, you get some of the nice Golang advantages, such as marshalling into JSON and XML. So the protocol buffer backend doesn't give you all the formats right now. It's something that Spiros is working on, but we will get that very soon. You can get BGP updates at this point through this interface, and hopefully everything else within the next few weeks. Okay, a different service that we provide, and this is from my student Anand Shah, is an autonomous system and prefix geolocation service. We will present this at Apricot at Ho Chi Minh City at the end of the month, if anyone is there. So we'll see more details in that presentation. So the goal here is to try to put some geolocation information into autonomous systems and prefixes. Clearly, a static database is not going to cut it because databases, geolocation databases can be wrong, and they are usually outdated. But also prefixes get traded, so they move around. So having a service that would look at this and that do the resolution dynamically is useful. It is a simple lookup function at this point. So what you do is you provide a prefix or an autonomous systems number, a month, and then what you get back is the number of countries that the prefix or the ASN geolocates to. And as I said, it's good to have this as a dynamic service. The other thing that this service can provide is a historical record of AS or prefix to geolocation. So for example, if a year later you wanted to know where this prefix geolocated, because perhaps it has moved, you can make a request into the historical archive and get that geolocation. The service works now. My student is working on adding more months, so you can do these queries over multiple months, and hopefully we'll have that done in a few weeks. Now, this is how we do the geolocation. Now, we don't do the geolocation ourselves. We rely on geolocation databases. And the way we do this is fairly simple. We take each prefix from the BGP table, break it up into /24s, do a geolocation lookup for every IP address, and then collect the countries that these prefixes geolocate to. Now that gives us the prefix geolocation. If we take all the prefixes advertised by a particular AS, then we now have the geolocation for the entire AS. And note that in some cases, the country, the particular prefix or a particular AS may geolocate into multiple countries. We currently use MaxMind to do this, but there's other databases out there, especially paid databases, that perhaps can provide more accurate results. And I stress that we only do this for now for country-level geolocation. We could do this for finer-grained geolocations, such as cities or even more, but at this point, we only provide this service for country geolocation. The reason we did this is because we wanted to investigate something, as I mentioned earlier, that's called an international detour. And just to remind you, an international detour is a path, it's a BGP path, that starts in some country, ends in the same country, but happens to go through a different country or countries. Why is this interesting to study? Well, there's a number of reasons why you may want to care about this. If you are business-oriented, you may want to see, for a particular geographic location, how many detours are happening. That could be because the particular geographic location is not being served very well by network infrastructure. So there could be an opportunity to go in there and add more network infrastructure. Another reason is to potentially comply with the regulatory requirements. I'm sure a lot of you are familiar with regulations that are going on in Europe and Australia that require that user data, private user data, remains in a particular country. It's not clear that those regulations cover data in transit. I wouldn't be surprised if at some point it does. But if such regulations were to come about, you might want to know when private user data is moving around, what path is it taking? Is it going through a different country and so forth? Another reason might be to detect network problems. As we know, routing sometimes routes around outages, natural disasters, or things like that. So if all of a sudden you notice a lot of detours around a particular area, that could be an indication that there's a network problem that you may not have seen otherwise. And finally, if you are a little more conspiratorial minded, such detours may provide opportunities for other people to sniff your traffic. So you may want to know when this happens, especially when those detours are very short. So we did a little bit of a study on detours on the internet. This is just a small teaser from the results we found. This is a case where, this is about persistent detours. So most likely detours that happen due to traffic engineering. And we're listing the top ASN that where detours started. That's NTT Communications in Brazil. The common destination of detours, that's Telecom Italia. And the percentage of detours that happened by this pair. And then finally, the percentage of detours that ended up in this particular destination. There's a lot more of these results in a paper that my student published last year. Here's an example of a transient detour. This is a short-lived detour. It only lasted a few hours. And as you can see, it belonged to a prefix owned by the DoD, and it's a detour that went through Japan. Now, we don't think that there's anything wrong here, but it's just an example of a transient detour that we have seen. And depending on who you are, you might be interested in knowing more. Okay. So on top of the archive services that we provide, we also provide a hijack service. Now, this is currently in beta, and we're working with Charter, and I do want to thank the Charter folks, especially Rich Compton and his crew, for working with us on this one. And we're starting this with Comcast too. So we want to learn how to provide hijack detection in a useful way for you guys. The process we're following right now is you give us your autonomous systems numbers. We go off and find out what prefixes those ASNs advertise. We come back to you in case you want to check the prefixes that we found. In the process, we may have found a few other autonomous systems numbers that belong to you that perhaps were missing from the original list that you gave us. That happened with Charter, for example. Then we start monitoring these prefixes. But there's a learning period where we try to find who your customers are, who are the legitimate autonomous systems numbers who should be advertising your prefixes. And that takes a few rounds. And we came up with a few ideas on how to do this with Charter, but that still remains a hard problem because at the bottom, what we need to know is who you have business relationships with so that we don't send you alerts from your business partners. So it's an evolving process. We're using historical data to learn these things. For example, if a prefix has been advertised for a year from a particular AS, that's probably not a hijack. So we're rolling this out with a number of people, those who want to spend some time with us and help us understand what is the best way to do hijack detection. So if you're interested, just send us an email. We'll be happy to work with you. Another service that we want to add to our database is data plane outages. So control plane outages are easy. We can see them on the BGP plane. What's really interesting is to put the data plane outages in the database and then compare control and data plane outages. I think for researchers, that would be really interesting. For operators, I think it might be interesting too. So we're working with one of my collaborators, John Heidemann at ISI, who is doing data plane outage detection. And he's been keeping a historical record of the data of the outages that he's seeing. And the goal is to try to include those into our database so you can also get those. Okay, so in conclusion, we're doing a clean slate implementation of the old BGPmon. Our focus is very strongly on serving the community. We want to build something that you guys can use. And that sets us a little bit apart from other efforts such as RIPE or BGP Stream, where they give you a nice interface. I mean, they do a great job, don't get me wrong. They give you a nice interface where you can go and pull out information that you want. We would like to give you the ability to look directly into our data. So we're providing many ways to access the data in different formats. We've got a few new services that we're providing. Let me just close by inviting everyone to, so the part of the reason why we're here is to hear from you guys to tell us whether what we're doing seems reasonable, seems wrong, and get suggestions about what other services we can provide. So let me close here and open the floor to questions. And please give us feedback. Don't be shy, either now or via email. And here's our contact information. Thank you very much.
Good morning, Matt Petak, Yahoo. So one of the persistent challenges that people have, I love the idea of a AS geolocation service, but the number one complaint from users is, oh, you've geolocated me to the wrong place, and well, some database or another has the information wrong. It sounds like you're pulling from MaxMinds. Are you going to provide any kind of a way for people to update or override the MaxMind information, or are you just going to punt them back and say, talk to the guys at MaxMind if you're in the wrong country, so sorry?
That's a really good suggestion, and yes. We want to have an open channel to the users to tell us, no, you're wrong. Whether it's geolocation, whether it's an outage that we get wrong, whether it's a BGP problem that we get wrong, we want to keep that feedback channel open.
Awesome, thank you.
Sure.
Slobna Guda from Newstar. I have a question because some companies or services DDoS mitigation. And basically, the way it goes that they have to register the prefix of the customer under their DNS. So how you deal with that? Because most of this stuff is manual, and then they get synchronized across the database.
Yeah, that's a really good question. That's part of the challenge of figuring out business relationships. So that's another case where we have to be careful about who we attribute a particular prefix. I don't know exactly how these companies do this, meaning whether they do this as a long-term registration or whether it's something that happens in the short term. But I think that's a really good thing to look into.
Basically, it's like as long as the customer is their own customer, so it's
Right. So it will be so. I think the only way to do this is to talk to the customer, and so if it's a long-term thing, we would probably take it as normal condition. Wouldn't raise any alerts. The problem may arise if someone is under a DDoS attack and all of a sudden the registration changes, and then we detect it, and we raise an alert.
yeah. I just wanted to raise that the registration can take a long time,
Yeah.
but the announcement is not.
Exactly.
So that's
Yes. Yes. So you're right. We need to be careful about that one.
thank you.
Thank you.
Heather Schiller, Google Fiber. To answer that question, usually the mitigation provider will announce the prefix on behalf of their customer. So the origin ASN will typically change to be the mitigation
Right.
provider. But presumably if the customer who's under attack is also monitoring their prefixes, they know they're under attack and that they've been put into mitigation. So the generation of the alert shouldn't cause too much problem for the customer themselves.
Yes, and actually, I think what you're telling me is that we may provide a way for the customer to verify that the DDoS protection is taking place. So I think that's nice. Okay, great. But thank you very much.